Welcome back, everybody. Thanks for tuning back in. We're going to talk about defrost clocks. What I'm holding up in my hand is a defrost timer that is typically installed on a walk-in cooler or walk-in freezer or some type of refrigeration piece of equipment. And we're going to talk about the importance of this. We're not going to get into a whole lot of the wiring, but we are going to talk a lot of key notes on what this is typically used for and the efficiencies of it and why it's so important. And then the terminals that are inside that we are connecting our wires to, what do they pretty much go to? What's an input? What's an output? Just a general guideline just to help you navigate through some of those things that you may have forgotten. If you are in refrigeration, this is going to be something that you do a lot of. A lot of times you may just be taking one part out, putting the same part back in there wire for wire, but you want to make sure that you fully understand this. So, as you're explaining it to the restaurant owner or manager, or you're training somebody, or you're just setting it up for yourself, you have that knowledge of the reasons why it's important to set it at a certain time, a day, or duration, and then defrost termination sensors and whatnot like that are important. Stay tuned. We're going to take it through step by step very quickly. We will release other videos that regard how to wire that up. That won't be on this video, but stay tuned. Thanks. Okay, behind me I have a picture of a frozen evaporator coil. This is in a walk-in freezer, but it doesn't matter. It can be a walk-in cooler. It's going to look the same. If your coil's frozen, your coil's frozen. All right, so it doesn't matter if this is a cooler, it doesn't matter if this is a freezer. That's what they look like when they're frozen up. So we have to ask ourselves, why did this coil get in this condition? Did they leave the doors wide open? Were they loading the cooler box up with new product? Were they cleaning it out maybe? Were they doing any type of work in there while the system was running with the door open to allow humidity to go in there, because that's pretty much what's frozen. Now, were fan motors not running and the compressor running? Did this thing miss a defrost cycle? Is the defrost working properly? There's many things. Are they running the thermostat down too low if it's a cooler with no defrost capabilities? These are the things that we have to figure out when we're doing refrigeration. These are the things that we need to know. These are the things that we need to understand. And one of the things that is complicated in refrigeration is when we get into freezers. And it's not because we don't understand a refrigeration cycle at that point, right? It's because we don't understand these defrost termination sensors and defrost clocks and, the heating elements and, the sequence of operation, basically. And we're not going to talk in this video, like I said in the beginning that, of the video, about how to wire this stuff up and all that, because there's going to be other videos that we released that talk about that. We're just going to get right into everything that you need to know in a nutshell. If you had to, understand this to a point to explain it very simply, the benefits, pros of having a defrost clock, and if it's a cooler or a freezer, and what that you can expect and what it can do for the equipment. So I've got a lot of boxes. I got a lot of stuff here. So I'm just going to kind of start from the far left, and we'll move across the screen to the right. And then we'll come from the top down and all these things that I put on here. Coming over here to the far left, I've got two questions. Question one, why does my cooler freeze and what can we do about it? Okay, a cooler is not supposed to freeze. A cooler is supposed to keep a low temperature, right? We're supposed to be above 32 degrees, right? Above the point where moisture freezes. So if that cooler freezes, and we know that we're not having mechanical problems like restrictions that throw off superheat readings. If we know that we're not leaving the doors wide open and people loading that product into the cooler and all that humidity getting in that box at a 34-degree temperature, that could cause it to freeze too. What else could do that? How could it just happen on its own? You know, you could have a thermostat that's just kind of going haywire, and the system could be running longer below that 32-degree threshold. That's common. But if you're out there repeatedly and you're starting to have callbacks and your client's getting frustrated, you may need to put a defrost clock on that and have a air over defrost. So there's one thing you can do if it's a cooler. So why does it freeze? Well, moisture is what's freezing. It's at a low set point, and what can we do about it? If there's nothing mechanically wrong, we can install a clock, and that clock could allow it to maintain that efficiency. So we'll get into that in a second. Look at question number 2 down here. Why do I need to terminate defrost on a freezer? I chose these 2 questions because they're very random and most people don't really address these properly, in my opinion. But why do I need to terminate defrost on a freezer? If you look in there, you'll see that this X terminal there, that defrost termination sensor is wired to. It's optional. I don't think it should be optional, and I'll get into that in a second. However, why do I need to terminate a defrost? We're going to cover that. We're going to cover that. Why does my cooler freeze, and what can I do about it? Coolers are not supposed to freeze. Freezers are supposed to freeze, right? Because we're below 32 degrees. Coolers are above 32 degrees, right? So one's supposed to freeze, one's not. Very simple. What can we do about it, though? Put a clock in. Why do I need to terminate a defrost sequence when I'm in the middle of a defrost? If your coil is thawed out and there's no more ice on it, right? And you're still in a defrost, why don't you want to get out of that defrost cycle? That clock, it cannot take you out of a defrost on its own, because its design is for it to have a duration that you set for 30 minutes, 45 minutes, 10 minutes, 15, whatever you set that duration for. It's going to run that entire duration out before it comes out of a defrost. So why is it important to have an ability to terminate that? Because if you are thawed out and you're still in a defrost, you can damage the actual heating elements that are running through that evaporator coil. Those heating elements run through that coil as they are energized and creating enough heat to thaw that coil out. You want them to no longer be energized if there's nothing else to thaw, because what will happen is over time they'll start to warp and they'll start to pull out of that coil. So if you've ever looked at the back side of an evaporator coil that's in a walk-in freezer, you may have seen on older models where the coil has the heating elements that are just warped out of it. They're just kind of like bent, like they're not even in there. So think about that for a second. Couple questions need to come out. Like, 1, how did that even happen? And 2, what's going to happen with those not being inside that coil? So let's answer that first question. How did it happen? Well, you did not terminate the defrost. Simple as that. Okay? Now, what's going to happen once those heat strips wind up warping out of that coil? Well, very simply, you're not going to be able to thaw the ice off the coil. Why? Because the heating element is not even in the coil anymore. You see? So, why would we need to terminate a defrost time? So that doesn't happen. This is just that simple. And then also, during defrost, we're no longer in the cooling cycle, right? And so, we start to slip away from set points very quickly. We want to get back on track. We want to make sure that we're maintaining a good box temperature. So you want to think about the efficiency overall, not just the reliability of the equipment and the safety of the equipment. So, all right, so why does a cooler freeze and what can be done about it? Okay, think about the walk-in traffic 1 to 4 times per day. All right, if you're walking into the walk-in cooler, you're opening the door, humidity's coming in. If you're running 34, 36 degrees, humidity's introduced to the box. Humidity's going to stay there. That humidity will collect on the coil. Obviously, it's going to run into a pan and out the drain line. However, sometimes set points do slip past their point of the ability to open and cycle everything off, and they do run a little longer. That being said, the timer will maintain the efficiency of the equipment, which will increase the cooling capacity. You know, obviously, if you're running at low temperatures, it's also very important to maintain the efficiency of the equipment. So when your coil starts to frost up, when your coil starts to freeze over, it's not ever going to be able to stop until it has thawed itself out. Now, there's a couple of ways of doing that. The most efficient way of doing it is with heating elements, but your coil has to be equipped with those elements. You're not really putting that in. It's kind of already built into it. When you order it for a freezer application. In this situation, if you're dealing with low temperatures and it's a cooler, okay, then you want to think about, all right, I need to run a very cold box, right? And with that, there's going to be the potential that it's going to freeze up. So how do I regulate that if I don't have heating elements? It's very simple. It's called an air over defrost. So you can just simply wire this clock so it just runs the fans in the box, right? So you're still getting air over the coil, right? And coil's already cold, but you don't need that compressor operating, right? That compressor can shut off. And so if that compressor cycles off, all right, for the duration of the defrost time, so you set it for 15 minutes, 20 minutes or whatnot, compressor is off, yeah, you're going to raise that box temperature a little bit, but you're not going to get past a critical point to where, you know, there's going to be an issue there with the product, right? And then if you did that several times a day, you can maintain these lower set points and not have the potential risk of freezing the coil up. So when we start getting into coolers with lower set points, then yeah, we're going to have to introduce a timed defrost that initiates however many times a day, 4 to 6 times a day, right? Where we're just running the fan only, even during a call for cool, but the compressor is not running during this time, right? So there's no heating elements here. We're not using it for a freezer. That's only for cooler applications. Very simple to do. You can do it for reach-ins. You can do it for walk-ins, any cooler applications. Now, if you're running a freezer, you have to have a defrost clock. Why? Because we're running below a freezing point. Moisture is going to eventually freeze. We're obviously going to lose efficiency. We don't want to wait for the coil to be frozen. We just want to make sure that if this product is maintaining a temperature and, you know, we're not going into the box and allowing a whole bunch of traffic during the wrong time of the day to have a defrost. Let me get into that in a second. Then you need to make sure that that defrost clock is not initiating the defrost during those peak hours. So let's break that down for a second. Let's just say that it's a breakfast joint, right? And so we're going in the walk-in and we're getting all the product out of it. And at the end of the day, you know, we got to clean up afterwards, right? Well, if I'm going to have some downtime and I'm going to be cleaning, the last thing I want is to have that freezer running in freeze mode, right, with the door open and me loading product or moving product around and cleaning up. Maybe I'm getting ready for a health inspection, or, you know, so you want to make sure that you understand your restaurant schedule, right? And they always have a schedule. Who's coming into work? Who's not coming into work? What are they doing throughout this day? Once a week, we got to shut everything down and move this around and clean this. Whatever that's going to be, it's typically around the same time. May not be on the same day, but it's always around the same time. You want to be able to take note of those times, and you want to make sure that a couple things are being done. One, you want to make sure the clock is set for the right time, right? So if they're going to be doing this right after they serve breakfast, and it's 10:30 in the morning. That's their downtime. Okay, then at 10:30, I would have that thing set up to do my defrost cycle then. Why? Because probably by the time they're done with all that, a lot of humidity is going to be in that box. I've already ran for a very long time while they're walking in and out of it anyways. So I need to make sure that I'm keeping up with the efficiency of that, and I'm not freezing my coil in the process of all that. So setting the clock at the right time, and then the right duration of the defrost cycle, which we have some keynotes here we'll talk about, that would allow that freezer to maintain a healthy box temperature around those time windows. Same thing. Maybe I'm going to be doing a restock every Friday, and the food truck's scheduled to come in at say 2:30 in the afternoon. And okay, so it's not there first thing in the morning, right? It's there right after lunch, and it's before dinner. So that would be a good time to set your defrost clock up to go into a defrost during that time. Why? Because the door is going to be wide open. People are going to be going in and out of it. They're going to be moving product in and out of it, or moving product around, cleaning it, whatnot. So humidity will be introduced to the box. A lot of the times when these freezers wind up getting into these conditions, there's a lot of simple things that could be alleviated to not allow this to happen. This doesn't mean that there's a mechanical issue all the times. A lot of the times, it's just simple timing on the defrost clock, or maybe the clock's just not going through a long enough duration. There's something right there. So you always want to look at those very basic things first. Okay. And so you want to think about the walk-in traffic. Okay. And I want to make sure that if I have heavy walk-in traffic, I'm not adding to the problem by turning off my defrost. I'm sorry, turning off my equipment because of a defrost, right? Because you may be having heavy traffic for hours on end, right? So let's just take a restaurant that is serving dinner from the hours of 5 o'clock to about kitchen hours of 10 o'clock. That's a 5-hour stretch. People are going in and out. All right. Well, if they're going in and out of the walk-in, the last thing I want to do is have my defrost clock scheduled during that time window to go into a defrost too. Again, somebody can simply go, all right, I'm in the middle of a defrost cycle. The box temperature is going up because the door is open and closed. Somebody can simply look at the temperature gauge and say, hey, the temperature is higher than it's supposed to be. I have a problem. By the time your technician gets out there, there's not even an issue. It's now charging you for a fee because simply the system was simply doing its job. It was in a defrost. All right, very, very common mistakes that are made. So how many times? 1 to 4, 1 to 6, 4 to 6 times a day. However as much as needed based off of the client, right? If that door is going to be closed, right, for a long period of time, I don't really have to worry about defrost that much. It's really once the humidity is introduced to the box. Because after we go through a defrost and, there's no more ice on the coil, it's completely thawed out, we're going to get 100% capacity out of that. It's going to drop temperature faster. It's going to maintain that efficiency until we start opening and closing the door. That's when we start losing that efficiency. Now, it can maintain if it has enough horsepower and there's no mechanical problems at the box temperature. However, defrost is really there to thaw built up ice. And so you're going to get the majority of that while you're utilizing the box because you're introducing that moisture. This is a common thing that people don't think about, is how does the moisture even get in there? It gets in there by the act of you opening the door. And so I don't want to go through a defrost until I'm at the very end of that peak time, right? So if I started cooking at 5 and I'm done cooking at 10, time to clean the kitchen up, maybe around 10 is a good time to set that defrost clock to run 30-40 minutes, right? And then maybe I'll do it again in the middle of the night, and I'll do it again before we start our day, and then I'll do it again between the the next peak hour to peak hour. You always want to set that to when it's going to be not in the middle of a shift, right? So very important. The time of the day needs to be correct. Sometimes we lose power. Somebody can turn a breaker off. Somebody can be maintaining the equipment or changing out another part somewhere else on the equipment where the power's off. Now that defrost clock is de-energized. You figure a couple hours here, hour here, whatever. Now it's out of schedule. So whatever it was originally wound up to and set for, if it's 9 o'clock real time, the clock needs to be at 9 o'clock. If it's 9:30, it's 9:30. It can't be 9:30 at night and the clock's reading 2 a.m. That's not going to work out. So very common problem, simple solution. The defrost duration. It needs to be, what time do I set my defrost to? Okay, long enough to thaw the coil. So think about the application. How much traffic is in and out of this thing? If I had a lot of traffic, if I was at a high-end commercial restaurant that, was really utilizing this box, and, when they took on their deliveries and that door is wide open for 20-30 minutes and they're just constantly going in and out of there, I'm going to want a longer time because there's more humidity built up at a low temperature. And I want to make sure that I can reduce that moisture. And that moisture is going to wind up on the coil. Eventually, it's not going to come off the coil. It's going to just get frozen onto the coil, right? And so that's great because if it's on the coil, it's not in the air, right? So now it's time to thaw that out so it can run out the drain line. So, how long should that be? I don't know, 20 minutes, 30 minutes, 45 minutes, longer. As often as we do this, there is no set what time should it be. You just have to understand the box, understand the demand of the restaurant, the piece of equipment, right? That heat load. You may have a door seal that's gone out and you're getting moisture in there no matter what, and they may not even have a door closer or even be good at closing a door. It could just be sitting there cracked open. The practice of the people working there of opening and closing the door have a lot to do with defrost settings, right? So if you had a restaurant that was just really jammed up and very strict, then you're going to probably be able to back that time down. But if I had a restaurant that wasn't so strict on the door policy, then I'm probably going to have more trips out there for service. So I'm going to set a longer defrost time just to help reduce that moisture, right? Because more moisture is going to be in the box. So 20 to 30 minutes is what I put up here. But if you look here, it says long enough to thaw the coil. All right. The defrost needs to be terminated if the coil is thawed. If the coil has no ice built up, no frost on it, all right, we shouldn't be in a defrost cycle for another 10-15 minutes. That will damage the heating element. It will warp outside the coil, and now we don't have the ability to thaw the coil anymore. So we have to protect that. And the only way to do that is with a sensor. So the defrost needs to be terminated if the coil is thawed, and you need a sensor. Okay. So we're just going to continue to move on. I got 3 things in green here. 1, this defrost clock is going to maintain efficiency of the equipment. How? Because cooling capacity is going to be higher, and it's going to maintain efficiency if we're running at lower temperatures, right? 2, this defrost clock will, the ability to defrost for a proper operation, right? If this defrost clock is not here, then we're not going to have that ability to defrost for a proper operation. So a couple things over here. Ice can't thaw without help. You have to manually thaw it or have a clock that's scheduled to just shut everything down and turn on heat strips during that process, and then turn it all back on after so long of defrosting. So it has to have help, right? Well, this is the helper. The defrost can't terminate without a clock. So you also have to think about that. If you were to put it into defrost, right, how could it ever come out of defrost without the clock, turning everything back into its normal cool mode or freeze mode? 3, clock can be used for air over, right, for cooler operation, or defrost applications on coolers and freezers. All right, so if we're going to do this for air over, we just need to cut the compressor off. That's it. We're going to run the fans over it. That will fall, right? Because the moment you stop allowing your refrigerant to go in the coil, it doesn't have the ability to create ice anymore, right? So just a fan running over it naturally would thaw any frost built up if it's for a cooler. And B, you know, if it's for a freezer application, it's there to turn that off and run the heating element, right? So this is what controls that heating element, right? So very important. Now we have all these terminals on here, right? And it's not one model is the same as the next model. These are all different models. I have an 8145 up here, which is a very popular model. I have terminal 1, 2, terminal 3, terminal 4. I have terminal N, and I have terminal X. I want to go over these terminals real quick. If you see here, terminal 1 and 2, right, there's this little bar here that's connecting power from terminal 1 to terminal 2, right? Terminal 1 has a specific job, and terminal 2 has a specific job, right? And depending on my application of the clock is if I need to have this bar here, right? So if I want to energize the clock by itself so the motor can actually turn and keep track of the time, then I'm going to have to energize L1 to terminal 1 and then L2 to N. So I'm going to apply 208 volts between terminal 1 and N, right, with L1 and L2, and that's going to energize this clock so the motor, the timer, right, can start working. Now, the other terminals are either going to be inputs or outputs, and we're going to go over that. So terminal 3, that's going to power the heating element at the evaporator coil. Terminal number 4, that's going to power the compressor and the evaporator motors, right? So the evaporator motors and the compressors are in 2 different locations, most likely, unless it's a packaged unit. But the evaporator motor, typically it always runs, even when the pump down valve is in the closed position. And if it's in a closed position, then gas is not moving through the coil because the compressor is off due to low pressure, right? And so if that is happening, the evaporator motors are still running. But if we need to get this thing to come into a defrost, then we need both of those things to cancel out. So we have to make sure that the pump down valve is in the closed position, right, despite the call for cool. That way, no gas can go through the coil because it's out on low pressure, right, by design. And we want to make sure that those evaporator motors are not running, right, because if we're trying to allow the heat strips to do their job, then having a fan running across those heating elements, they don't produce that much heat, right? It's not an air conditioner, right? You're not going to be able to defrost efficiently. So you need those motors to cycle off. And so terminal number 4 is going to cancel out the power to the compressor and the evaporator fans. Terminal X, okay, got many things here. Terminal X, when it receives power, it opens up terminal 3. It closes terminal 4. Okay, the defrost is terminated by a sensor, so a sensor is sending power back to X, and that sensor is just looking for 50 to 60 degrees because that's obviously evidence that it's no longer ice. You're not going to have ice present at 50 to 60 degrees, right? And so once you're in a defrost, there's no sensor that says go into a defrost. right? It's not a heat pump, right? That's why it's a timed defrost, right? And then at the end of the day, the only thing to kick it out of that is to know that if we don't need to go the entire length of time, so if I set my defrost clock for 45 minutes and I'm good after 20, well, my defrost termination sensor, if it senses 50 or 60 degrees on that coil, it can send power back on terminal X, and then X can remove power from 3, which kills the heating element, right? And it can put power on 4, which brings my compressor back on and my evaporator fans back on, right? So pump down valve is now open again and the evaporator fans are running, right? And so this may look like it's still in a defrost here, but the clock is doing something different. So because you put power on X. If I wanted to just test that and I didn't have a defrost termination sensor, I can simply take power from in and just jump it to X just to make sure my clock worked correctly. And by doing that, 2 should make 4 and 1 should open on 3. Again, we'll do that on another video where we get more detailed on the wiring. Coming up here, terminal key wiring notes, very important. Input and output, input, output. If you watched any of my other videos, I'm big on input and output so you can understand the signal of flow, where's power coming, and where's it leaving, was it going to, what's it coming from, all that stuff, so we can better understand what's going on. We don't want to just know what kind of voltage we're getting, we want to know where the voltage is coming from. That's how we better understand sequence of operation. So, terminal X, it's an input. Terminal N is an input. These are getting power from L2, right? Very important. You got to know which one's L1 and L2 so you don't butt legs together. X is coming from the sensor, okay? That's where L2 is coming from. N, well, that's coming from the power supply. You got a 2-pole breaker, all right? Now we have 1, 2, 3, 4, all right? These are 1, 2, 3, and 4. So 1 is an input, all right? That is from the power supply. 2, that's also an input. That's from the power supply, okay? So we know that L1 and L2 are both receiving power coming from the power supply, and they were both inputs, and we know that they're L1. Terminal 3 is an output. This is going out to the heater. We know that that is L1. And terminal 4 is an output to the compressor and the fans. That's also 1. And so if we looked at our clock very simply, then we can say that terminal 1, 2, 3, and 4 are all one leg of power. And terminal N and terminal X are another leg of power. So L2 over here, L1 over here. So yeah, you can literally take your meter out and you can start reading 208, 208. You know, depending if 1 is energizing 3, I'm going to read 0 between those two terminals, right? If 2 is energizing 4, I'm going to read 0 between those two terminals. If 1 and 4 read 0, right, then I'm reading 0 between those two terminals because it's still L1, L1, L1. And so there's, you know, we're going to get into that on another video so we can start wiring this up and we can start seeing where we're going to read power. If you watch any of my other videos, I'm really popular for telling you where your voltages should be at. But because this is a 208, 230 application here, I'm going to either read 0 volts or I'm going to read 208, 230 volts. Remember, 0 does not mean that there's no voltage. 0 just means I'm on the same leg of power. So if I'm reading across two terminals and I'm reading 0, that doesn't mean that there's no power present. Now, if I put one leg on one terminal, another leg on ground, a good ground that I knew was a good ground, and I read 0, then it's kind of safe to say that there's no power there. And I would test that on many different terminals. If I still read 0, it's safe to now work on. We'll catch up on that on another video. This is pretty much everything in a nutshell. It's a lot of information to take in. It's a lot to digest. I didn't want to do this over too long of a video because we're going to get into more specifics that we can bring all this information back in little by little. But just to kind of give you in a nutshell, you know, questions, answers, you know, hopefully this helps you out. If you pretty much know how to wire this up because you have one that can just plug and play, that's understandable. That's how everybody gets started. But if you had some quick questions on what's that for, what's that for, what's that for, this video explains all that very simply. So I hope this helps you out. We're trying to give you guys consistent information. We're going to take you through this section of videos with defrost clocks and freezers and coolers and different components that are in there. And once we're done with that, then we'll get into our next series, which I'm not going to tell you what that is, and it doesn't really matter where you're coming in on the timeline. We have different playlists if you want to look at that, or if you just want to look at any of our videos, watch them all. They're very informative. There are a lot of those videos on air conditioning. We're just now getting into the walk-in coolers and freezers because we had a request from one of our viewers, one of our subscribers that was asking about that. Leave us a comment. We read those. Listen, this stuff is not that easy. If there was not a shortage of technicians, one day I'd be very surprised. This is a complicated industry. It's a vast industry. We're here to help you with that. We care about you. We're here for you. And this is our industry. So it's your job to take this information, not just hold this information in, but share this information with someone else. If somebody's going, man, I wish I knew about that, and they don't really work on it, say, hey, look, follow this channel. They talk about that stuff too. If it's hard to explain this stuff to your client, show the video. There's nothing wrong with that, right? It's nice to be able to, have this platform to share this information with you. Don't let it stop there. Share that. Like the video. That really supports our algorithm, right? Helps us get found more. And obviously, if you haven't subscribed already, please do so. And we appreciate that support. Thank you. And as always, stay safe.